Hello students, I am Professor Gadak RS from Sundarabai Manik Adsul Polytechnic, Chas, Ahmednagar. Today we are going to learn the problems on cantilever beam. Let's start the session. Example, a cantilever beam of span L carrying a UDL W over entire span. Draw SFD and BMD. Let's start the solution. Okay, read problem carefully. A cantilever beam. All of you know that cantilever beam means one end is fixed, other end is free. Of a span L, having the span is L. Suppose fix the point is A, the point is B. This cantilever beam carrying a UDL W. All of you know that. What is the UDL? UDL means what? The load which can spread over a beam per unit length. This is called as a UDL. Uniformly distributed load having W, small w, in Newton per meter. Means what? This cantilever beam carries a UDL, this W per meter length. This is our example. You have to draw the SFD and BMD of this cantilever beam. And this is your loaded beam. Okay, if in that problem suppose cantilever beam with a UDL, in a very first you have to convert that UDL into the equivalent point load. Remember this concept, equivalent point load. How you convert the equivalent point load? This UDL. This UDL W into the length is L. Means equivalent point load is W into L. And note that you have to act this equivalent point load in a mid span of this beam. Equivalent point load is at in mid span of beam, or you can say that or UDL. Okay, this is very important. You have to convert that UDL into the point load. Means that act into the mid span. Total span is what? L. Mid span is L by 2, L by 2. That is very important. Okay. The step number 1. And all of you know, in the previous examples, we learned the step number 1. What is step number 1? To calculate reaction RA. For that, you have to use the sign convention. Summation f of y is equal to 0. Upward positive, downward negative. This RA is acting at a fixed end RA. Okay. This RA goes to the upward, take it positive. RA. This WL, this point load goes to the downward, consider negative, minus WL is equal to 0. Only this 2 point load is acting on the cantilever beam. That's why we have to consider only the 2 point loads. Calculate this. RA is equal to W into L. And this is the RA. W into L. Okay? And all of you, this is the reactions. Next step, step number 2. To draw shear force diagram. Before start to draw the shear force diagram, you have to draw the projection of this free end and then fix the end A. No need to draw the projection on this equivalent point load, because you have to convert that UDL into the point loads. Okay, remember that point. Okay, step number 2, to draw the SFD. For that, you have to draw the baseline. Above the baseline, you have to take the positive shear force, and below the baseline, you have to take the negative shear force. Okay. For that, while drawing the shear force diagram, you have to start from right to the left. Means you have to consider sign convention from right to left. For that, you have to use downward as a positive and upward as a negative. This is very important, and how that sign convention comes, that learned in the previous example. Okay, let's start. Shear force at a free end. Shear force at point B. Okay, shear force at point B. F is the shear force at point B is equal to 0. Why 0? Because at the free end there is no any point load is acting. Okay, the next point is what? Shear force at the point A. Directly you have to take the at the point A. Okay, consider up to the B to A, there is how much point load is there? Only one point load is there, and that is the point load is W into L. This goes to the downward. Consider plus W into L. Okay, shear force at point B is equal to 0. Shear force at point A is equal to plus W, and at point A is equal to plus. Plus means you have to draw the above the baseline. Means this is positive. W into L. This is your A point. Okay. You have to draw the shear force diagram. Okay. In between A and B, there is a UDL. Means you have to draw the inclined straight line. You have to draw the inclined straight line, and this is your shear force diagram. Positive. This is your positive shear force diagram. SFD in Newton, because you have to consider that UDL in Newton. Okay. The next one is step number 3. To draw BMD. BMD means all of you know that bending moment diagram. For that you have to use the sign convention. Upward is positive, downward is negative. Upward is positive, downward is negative. And bending moment means what? Force. Bending moment means force into perpendicular distance about that point. Okay. While drawing the bending moment, first you have to draw the baseline. Above the baseline, you have to consider positive bending moment. Below the baseline, you have to consider the negative bending moment. And all of you know the concept. If cantilever beam is there, then you have to always start from the free end. That we learned in the previous problem. Okay. Let's start. Bending moment about point B is equal to 0. bending moment B is equal to 0. Why 0? Because free end. Or in the left side there is a no any beam, no any force, no any length is there. Okay. The next point is bending moment about point A. Bending moment about point A. Again, start from the free end. Force. In there at point B there is a no force. Okay. Next force is W into L. This goes to the downward. Take it minus W into L. This is the force and perpendicular distance about point A. Why about point A? Because we are calculating the bending moment about point A. And our concept is what? Bending moment is what? Force into perpendicular distance about that point. Okay? And this is force minus W into L. This is the force and perpendicular distance is what? L by 2. And our final answer is minus WL square by 2. Minus WL square by 2. This is the bending moment about point A. Okay. As per the calculations, we draw the bending moment diagram. At point B, bending moment is 0. Okay. At the point A, bending moment is minus WL square by 2. At the point A, bending moment minus means you have to draw the below the baseline. Consider here WL square by 2. No need to write here a negative sign because below the baseline itself it indicates that negative. Okay. You have to draw the parabolic curve. Why parabolic curve? Because in between B and A there is a UDL. You can say that this is a parabolic curve. And this is your negative bending moment diagram in Newton meter. In this way, you can easily draw the SFD and BMD of cantilever beam. I hope all of you understood. Okay, thank you.